So let me now introduce our next speaker. The way we always try to work on these Wednesday Keeping Current seminars is we have two speakers, if I can line up two people. And when I can't, sometimes I speak, but I try to limit that to once a semester. So here it is. So I want to tell you something about, is it work or is it play? I like that idea of work during the day and play at the night. And what I'm going to show you is playing during the day, which I can then call work, which is a kind of a neat trick. It's something I did starting many years ago. I see that Professor Victor Marek has joined us. It must be more than 20 years ago that he gave a talk at the logic seminar about logic puzzles and how one can convert that to answer set programming, which is still a hot topic and was becoming a hot topic at that time. And I was really enthused by that. And so I built some software. And so what I want to show you is logic puzzles and some of that software and the interactive software. So I'm going to share my screen here. Right. And let's put this far away here. Oops. All right. So what I do when I share screens, when I give talks, is instead of using PowerPoint, I just have a list of things I want to tell you about, and then I will do so. So the first thing I want to do is show you a simple puzzle. I think I'll do it on this, which has got a slightly larger font. All right. I built this particular puzzle as an example of the interactive tool, which I will be describing. Maybe I can increase the size of this just a bit. Let me see if that is going to work. Wrong direction. Yeah, that seems okay. Good. Now it's almost right. Good. So I have to read this in English, even though it's actually embedded in a language I invented called Constraint Lingo. So I have got 5 people. Each of them has a first name: Sam, Manethra, Norman, George, and Ashley. And each of them has a last name: Whatsit, Monroe, Broom, Smith, and Holmes. Extra credit if you know who has the last name Whatsit. And each has a favorite color: blue, red, black, green, and orange. And some of them are male and some are female. So when I say something's a class, that means that there's only one person called Sam. There's only one person whose last name is Monroe. There's only one person whose favorite color is green, but there might be multiple people whose characteristic is female. Right? Now, conflict Smith orange. The person whose last name is Smith does not have favorite color orange. Manethra and the person who, let's see, where's Broom? I don't even, oh, is there a Broom? A Broom, here it is. Manethra, the person whose first name is Manethra and the person whose last name is Broom, have different genders. Monroe has a favorite color red. Now, you have to look up here and see that Monroe is actually a last name person. Ashley and the person whose last name is Smith are the same as the person whose favorite color is orange and the person whose favorite color is blue in some order. I don't tell you whether it's Ashley orange, Smith blue, or maybe it's Ashley blue and Smith orange. The following 3 people are male. George likes red. Holmes likes green. Norman's last name is Whatsit. Sam and the person whose last name is Norman, no, Sam and the person whose first name is Norman, these are both first names, happen to have different gender. That is the entire puzzle. What's the answer? Well, let me show you first what the answer is from all of that, and then we can look and verify that these clues are in fact met. So let me run the program. There it is. There is the answer. And let's check the answer by going back to that program. And is it true that Smith and orange, Smith does not have orange? Well, where's Smith? here's last. They're in alphabetical order. Okay, here's Smith, and Smith does not have orange. And so you see every row here is one part of the solution, namely Norman Whatsit is male. Norman Whatsit is male and likes black. Manethra Holmes is male and likes green, and so on. So I'll just check one more thing. Is it true that Monroe, Whatsit, and Holmes are all male? Well, here's the three males. And there's Whatsit, there's Manethra, and there's Holmes. Let's see, was it? Yeah, Monroe, Whatsit, and Holmes are male, but it turns out that Manethra and Holmes are actually the same person. But this is the only solution to this set of clues. How do I know it's the only solution? Because the way I invoked it, I actually asked the solver, which is C Lingo. I asked it to give me two solutions if possible, and it only came up with one. That means that there is a single unique solution. Well, that's kind of nice that you can do that. And this particular puzzle I invented, but there are a lot of puzzles you can get from Dell Logic Puzzles. And I have, in fact, programmed many of them. And as I was building this language to represent things, I did it by looking at puzzles from the Dell Logic Puzzles in order to make sure that I could encode and solve them. Well, what does it actually look like inside? What I'm going to do here is I'm going to just run the first part of what I did. I have a script called puzzle2smodels.pl, and what I'm giving it as a parameter is this party program, and I'm just going to take the output of the script, which is before it's actually solved. This is what I actually handed the solver. Now this looks more or less like Prolog, which you might be aware of, you might not be. Things starting with a % are just comments. So I generate commented code. And I should tell you also that I introduce predicates for each combination of colors. There's each combination of columns. There's a column called color, there's a column called last, there's one called first, and one called gender. To avoid replication, I always put them in alphabetical order. So there won't be a predicate called last colored, but there is one called color last. And it's true if orange is a color associated with Smith. But I said in my initial code that Smith is not orange. So instead of saying color last orange Smith as a fact, I put it on the right-hand side of this arrow, the Prolog-like arrow, with nothing on the left-hand side. This is something new in answer set programming, introduced by answer set programming. This is called a constraint. It says it cannot be in any solution that the right-hand side is true because the left-hand side is empty. That's a notational definition of how an empty left-hand side works. In Prolog, of course, you can't have an empty left-hand side. When I say that Manethra and Broom have different genders, the way I do that is saying it cannot be that Manethra has a gender and Broom has a gender, but I have to know, of course, that Manethra is a first name, and so I call it first gender. And I have to know that Broom is a last name, and I can figure that out by looking at the program itself that I was feeding into this. And so if they both have the same gender, and a capital letter in ASP, just as it is in Prolog, means it's a variable that has to be instantiated the same way here and here. So if there is a gender that is Manethra's gender, and it's the same gender that is Broom's gender, that's not allowed. This just restricts that when I talk about capital G, gender, I'm actually talking about something of the category gender. You can ignore that. Monroe is red. That's the easiest thing to implement. I say that the color last of red is Monroe. A little bit more complicated, when I match Ashley Smith and orange blue, I say there's all sorts of things that can't be. it can't be that Ashley is orange and Ashley is also blue, because Ashley is only one of those two. So it can't be that Ashley's both. It can't be that Smith is both orange and blue. It can't be that orange is both Ashley and Smith. So these are all sorts of things that cannot be the case. And finally, I know that Ashley and Smith are two different people. And so I say that it cannot be that Ashley Smith is a person that is a first name, last name combination. Well, each of these input rules then gives me some sort of output. Then there's some what you might call boilerplate. I've got to tell the solver that the last predicate is true of Whatsit, Monroe, Broom, Smith, and Holmes. The genders are male and female. Certain things about existence, certain things about, these are boilerplate things, closures of predicates to connect attributes. I'll just read this one over at the top here. That says, let me read from the right-hand side first. If there's a particular color associated with a first name, and that first name is also associated with a gender, well, then that color is also associated with that gender. So it's the transitive closure of the rules that bind two columns together to generate rules that bind the other columns together. Right, so that then is what I generate, and then if I do a make again here, you'll see that what I just did here, I then put it through the solver, and the solver, let me just do that far and you'll see what the solver actually outputs. That's what the solver actually output, a whole bunch of stuff. It said that here's the first answer, and here are all of the predicates which are true. Now some of them I know they're true, like color red, that's not a surprise. Some of them are interesting. First gender, Norman male, turns out to be interesting. But it's not all that easy to read this. And that's why I actually feed that then through a script which examines that output and puts the interesting part in a nice chart like this. Right? So that was a simple, easy puzzle. I want to show you now a more difficult puzzle. This is one that I built, again. Small town motels. I'll read you the background story. John and Alice are the two owners of a chain of 9 small town motels, each motel in a different state, and each town, including Greenfield, that's just to introduce a name that didn't appear anywhere in the clues. Each town has a different name. Each motel is close to the town center of the principal street, on the principal street. Those streets have different names, including Willow, in each town. Each town was founded in a different year, including 1925. One summer, John and Alice decided to make unannounced one-week visits to each motel in order to evaluate the local management. Each of them picked a different order to visit the motels, but they might have met. From the given clues, determine for each motel what town and state it is in, when the town was founded, what street the motel is on, and the order in which John and Alice visited the motel. Sorry, these towns are so tiny you won't find them in any map or history book. In other words, these are all invented. And so here are the towns, and there are lots of them. Here are the streets. Here are the dates of founding. Here are the states in which they live. And here, 1.9. John has numbers 1 through 9. Alice has numbers 1 through 9. You can ignore this big comment here. So Alice's first stop was to London. Good. London is the same as Alice.1. John watched a different episode of a TV series on Maple Street in Port than in the motel that Alice visited fifth. And in the motel that Alice. So it's a fancy way of saying that there's certain things that aren't the same. In particular, Maple Street is not Alice's fifth row. And also, Port it can't be, okay, got to parse this. He watched a different episode on Maple Street and in Port and in the motel. These are 3 things. So Maple Street is not Port, is not Alice 5. So a conflict there. So this can all be reduced to conflicts and requires and some matches. That's all I used here. But it's a really tough puzzle. I'll show you the answer. There's the answer. It doesn't take very long for the computer to figure it out. On a somewhat slower computer, this is actually my laptop here, it took, that's about the same amount of time, 0.01 seconds to actually solve it. Good. And here's the answers, if you're interested. So Water Street is in Newtown, Tennessee. John got there first. Alice got there fourth, and it was founded in 1902. So now I want to show you the interactive program, which is the fun part. Well, it's all fun, but I want to show you interactive author.tk. So I'm actually going to run that now, and I'm going to run it here. Okay, you'll be able to see it. There it is. I unfortunately cannot increase the size of this. It's written in TK, and I never put in a way of increasing the size of the font. So this is what it looks like. But you can build your own puzzle here. Actually, you can load an existing puzzle. Here's an existing puzzle. This is a puzzle I made up called the Fearsome Heroes. It's based on the first generation of Star Trek. I'm sorry, second generation. And so if you look at this column, which has Data in it, Data is a crew member who fears Geordi, who comes in first at the Fizbin contest, whose hero is Troy, who comes in fourth at the three-dimensional chess, and who eats with Geordi. So columns that are in this light blue, those are classes. Those that are in this deep blue are actually called maps. So Data is mapped to Geordi, Geordi is mapped to Picard, Picard to Troy. It happens to be an onto map and a non-reflexive map. So here is the actual clues. And actually, I can ask it to solve the problem here. And there's the solution, and that's the only solution. And the solution is what you expect. It's right here. The way one builds a puzzle is to start with a solution and then to add clues. Now, how do I know that these are the right clues? Well, there's all sorts of clues that would work, but how do I know I need them all? Well, let me just remove a clue. Let me remove the fact that I'll take this one down here, which says that, let me not take that one. That one's too complicated. This one here. This says that there's an offset 2 in three-dimensional chess between Riker and the person who's second in Fizbin. I'm going to remove that clue. And now I will ask to solve it again. It asks actually for 3 solutions. The first one is right. You can see that there's some red in the background of answer 2 and answer 3. This shows that removing that clue makes the puzzle, makes the set of clues insufficient. And it was just one clue that was necessary to make that right. Let me bring that back the way it was. And I can also ask the program automatically to check, is every clue needed? So let me just add an extra clue. So I'm going to add an extra clue here. And so add a clue, and my clue is going to be, it'll be a simple one. It'll say match, and I can write it out or I can use this. Match Picard with Fizbin 2. Again, I'll solve just to make sure that that works. Now, why is solve not coming back? Did I misspell Fizbin? Did I miss? Oh, match is the wrong thing to say. All right, let's start this again. It's easy to make mistakes that cause it to wander into Neverland. So we'll start again. I'll load the thing again, and I didn't want it match. I wanted required. So I'm going to add that clue. Add a clue. Required. Picard and Fizbin.2. I think I've spelled everything right now. Again, I'll solve it. There, the solution still works. But now I can ask, are there any extraneous clues? And what it does is one by one, it takes out a clue and solves it and sees if there are multiple solutions. And already it's told me up here, you could omit required Gordy TD chest 2. It turns out that's no longer needed given the new one. I could also omit offset 2 TD chest Riker Fizbin 2. And so one by one it's looked at them, and it says that each of the ones that it's now put a red background in, these are clues which individually I could remove, and I would have now a usable method. So I'm just going to remove one of those and try again to solve it. Is it down to one solution? Yes, it's down to one solution. So as you add clues, you might over constrain, and that tells you if you've got more than you need. All right, let's build our own simple puzzle. So I'm going to start by quitting and starting again. I have no reset button. And I'm going to build a little puzzle. And it's going to have first, second, color, and position. Okay, I'm going to have, this is someone's first name. This is going to be the person's last name. This is going to be the person's favorite color. And here's the person's position in a line or something. And let's say I've got 3 people. So I'll add rows. So here is Alfred Newman. Color is black, and the position is 3. Here is Manfred Williams. Color is red, position is 2. And this is Joe Ellen Flatter. Color is green, and position is 1. Okay, that's the solution. Right, I have no clues yet. Well, let's add at least one clue. Let's put in a match clue. Let's say that Newman and Joe Ellen, let's see, no comma there. Newman and Joe Ellen are in some order, let's see, that's the first person and the second person, are in some order 1 and 3. Good, I've got that clue. Let's solve. Oops, something way up here. What does it say? No solutions. No solutions. How could there be no solutions? Did I misspell something? I misspelled green in position. That shouldn't make any difference. Well, let me remove that clue. I don't know why this is the case. Let me add a different clue. I'm going to put in an easy clue like a required. Required Newman and black. Solve it now. There it is. Okay, so it looks like I've got some solutions, at least 3, in fact, more than I want. So now I've got to narrow it down. Now looking at this, I can decide what's wrong. Well, it says that Joellen might be red. I want to say that Joellen is not red. That should at least remove this bad answer. So I'm going to add a clue and say conflict, Joellen and red. And now I'll solve again. Well, there's still at least 3 solutions. Joellen is not red, but there's still bad things. So let me now say that I'm going to add another clue and say offset. I'll use offset. I think I can get this right. Offset of, let's see, I want to get the syntax for offset, which I sometimes forget. So I'm going to look at that puzzle that we just looked at before, which was called hometown. Homes. Yeah, offset, here's the syntax. Offset how many and what it is, colon. Okay, so offset by 1 position, which I have to misspell, between Green and Williams. green is one smaller than Williams. Solve it now. Doesn't seem.
You misspelled
Well,
green. Green needs to be G.
oh, it's Geen, not green. Yeah. All right. So what I'll do is I'll save that current one in a temporary place. I can't even save it. This is the problem with writing software that you haven't and trying to resurrect it after several years. I don't have an easy way of interrupting this. There is no green, there's only Geen. But you get the idea. I could now add clues. Let me just start again. And I'm going to start again and do something simpler just to show you this. So start it again. And I'll just add one class in one row. Again, I'll have first and last. Norman Williams and Fred Flintstone. Shouldn't use long things that I might misspell. I will add a clue saying that required Norman Flintstone. Now this is a mistake because Norman is not Flintstone. But now I can say, are my clues consistent with the known solution? And up here, where I can't see it, it says, sorry, the clues do not yield the desired solution. But if instead of Flintstone, I say Williams, and now I say, is that consistent? It says in an invisible place up here, the clues are consistent with the desired solution. Great. Well, let's solve it. Hello? Well, obviously something is wrong with the with my underlying program because it's not coming back. But at least I've been able to show you some of what I have. Let me just cancel that. Go back to the one I started with, and we can try reading in the hero's problem again. This is the hero's problem, and we can now ask, is there a unique solution that ought to work? Yes, the clues yield exactly one solution. There is an undo, which only makes sense if you're not completely stuck. But let me open now for questions, and I can make this software available to you, but you've got to have the stuff necessary behind it. Namely, you have to have TK, you've got to have Constraint Lingo, you've got to have my scripts, and in particular, you've got to have the solver. But let me stop sharing the screen now and ask if there are any questions. The moral of the story, there's several of them. One of the morals is play and work can sometimes overlap. And if you're lucky, that happens often. And I find that my work often is playful, and I enjoy doing it. Of course, there are parts that are not playful, that are just work. But I consider myself very lucky that for many years now, I've been able to combine work and play, and let me wish that for you all. Another moral is, whenever you give a demonstration of things that work just fine, they will break. This is a known principle. And so don't let it upset you. You just back up and start again, because demonstrations always fail. Another is that when you resurrect old software, it is likely to be subject to bit rot. Bit rot, it's like dry rot. Bit rot is that the bits no longer do what they used to do because things they depend on have changed, the world has moved on, and so there is such a thing as bit rot. Those are the three morals then from this presentation. Send me email if you're interested in getting a copy of this software. And that's all for now then. See you all next week as we keep current.